Hello, good afternoon, everybody. Welcome to the stream. Thanks for joining me on Sunday afternoon. We're going to do some Elixir today, and hopefully about halfway through we'll finish up what we're going to do on Elixir, and then we'll revisit our implementation of Datalog in Rust. And I know I promised that on a previous stream, but we got kind of in the weeds with some of the Elixir stuff. But today, my goal is to polish up the documentation, add any missing features that I think should be there on our HTTP client, and then we'll do some data log in Rust. We had, gosh, it has to be 3 weeks ago now. Had my friend Quinn on, who helped us implement that first version of naively evaluated data log. Today on that, I kind of want to do a little bit of polish on that, so it's useful as a prototype, useful as a reference, and then we can play with it more on some other stream. So let's have a look at the agenda for today, and hopefully my cat will stop rubbing against the monitor. If you see the camera shaking, it's because she's on my desk. So apologies for that. All right. Oh, and my setting on that is incorrect because I switched monitors. My apologies for just a moment. I need to fix this. You're seeing my OBS. This is really awkward. Okay, and let's switch to the other monitor. There we go. That's what I wanted to show. Okay. Last time I had recorded for us that we should debug why xdoc was not working. It turns out that I submitted an issue to the repository saying, hey, between these point releases, it's not functioning correctly. Well, it turns out that all I needed to do was remove the doc directory and regenerate, and it was just fine. So thanks to everybody's pal, Jose Valim, for looking into that and telling me what's what. Okay, so the other things I'd like to do today, I had mentioned possibly on the previous stream that we do generate a client instance, at least the code for it, in the Hardhat module, and that's kind of a stopgap against writing a macro that doesn't work. We are always compiling a version of that macro so that we know that we are generating code, and we can use mix decompile to see what the macro generates. But it might be also useful, perhaps maybe in a live book scenario or something like that, where or an e-script where you want to take advantage of this, but you don't want to necessarily write your own client. You just need to make a few HTTP requests, and so I want to kind of support that possibility. So what we'll do is we'll create an application behavior, and then we will look at some of the config for the Hardhat application and see if it should start up the client. And if you configure it to have started up when you start the Hardhat app, then you automatically have that Hardhat module to be able to use in your e-script or your live book or whatever. The big thing, and this is probably not going to be the most interesting part, but the big thing that needs to be in this client before I feel comfortable releasing it as 1.0 is we need some discussion and examples in the README, and partly because those get injected into the Hardhat module itself. And so we'll do stuff like we'll talk about the application behavior, we'll talk about supervision, what you need to do to get it running in your own app. We'll make some example. We'll talk about the different things that are included. We'll make some examples for how you might tweak those or how you might use those to your advantage, and so forth. Kind of like more like a guide than module documentation. But in this case, I think it kind of makes sense to have that because you're going to use Hardhat in your own module. And so we need to have the documentation there for what the builder module provides in its macro. And I was looking at this before the stream started. I'm not sure if we'll do this, but it'd be nice to automate releases to Hex. So if any of you have experience with that using GitHub Actions, that would be awesome, and we can make a release action. And then I won't have to manually push from the command line. So anyway, that's what we're going to look at today. Let's get started. And we'll open reset Hardhat. Okay. So it looks like I have some changes that were not committed. Let's look. And I'm going to have to adjust my font size because it's too big. Let's go down to 13 and 11. Okay, that's a little better. Still pretty big, but it's a little better. And, you know, I recently, and I've been playing with the different themes. The other day it was, there was some things that were kind of in a grayish text like this that I couldn't read. And so I switched to Soloids Dark and it looked great. There was enough contrast there that I could read it. I think it was up here in the tab bar. It was disambiguating two files that had the same name, like which directory they came from. Anyway, let's see what's different. Right. Okay. So I just removed that comment. Let's see what was in the right. So I bumped this back up to 0.36. And then I forgot to remove the comment. So let's just mix study XS and commit that. Remove to do comment. Okay. All right. So we are going to look at adding application behavior. Now, if you've never done this, and you might not have if you might not have written it yourself, if you've just built a Phoenix app or something else that you know, was generated for you, you might not have done this. So let's go ahead and go here in lib. And let's make a new file and call it application.ex. Okay, and we're going to def module hardhat.application. Now, I think I had the docs up. Yep. Okay, so the application behavior is mostly, you mostly had used it to get probably keys that you configured your app with. So something like fetch env or fetch env with a bang, or even get env where you might return nil. But what we're going to do is actually do the callbacks. So let's go down here. Most of these are optional. The only thing that's required is start, and I guess stop. So let's see. Look at stop. Called after the application has been stopped. So I say it's not required. It is required, but use application will inject one that just returns okay. So let's go ahead and do that. Let's say use application, and we're already getting a warning. Undefined callback function start. Right. So what we need to do, we'll say impl application def start, and we're going to do module doc false. We don't need to document this necessarily. This is just boilerplate really for it takes 2 arguments. So what are the arguments? We probably don't care, but let's look at the docs. Okay, so start phase is optional. Start takes a start type and args. So args is anything that you pass, and we'll see where we configure this. And then start type is I think just temporary or right. So normal or takeover failover. And this is always going to be normal unless you're doing some weird stuff with Erlang application migration, and I don't see any use case for that for us. So we'll just ignore it. I'm going to go ahead and put in the names of these, and we will we'll hook this up later. Okay, so the thing that this has to return is so start. It has to return OK PID, and this PID is the root supervisor of your application. We don't have a supervisor yet. Luckily, Elixir includes a thing where you can say supervisor start link, and there are multiple clauses of this, so you can give it options. So I'm sorry, you can give it a list of child specs, which is what we want to do. We don't necessarily need to create another module that is the supervisor. We don't have any complicated startup stuff. So we'll just give it a list of child specs, and we'll construct that above here so that we can determine whether we want to start the default client. And then the init options are same things that we would pass to a supervisor. So strategy, probably strategy 1-for-1, name, etc. So let's do strategy 1-for-1. And then we can give it a name, hardhat.supervisor. Now we need to be careful here, because we're going to give the empty list for now. We want to not conflict with the name of the supervisor we generated in the builder, and I think we use soup rather than supervisor. I think I was probably thinking ahead to this possibility that we would want to create an application behavior for our library here. Okay, so this starts a supervisor with no children. It's kind of pointless. So and there's some other possibilities here. We could return a process which just exits, or just waits to receive a message which is shut down. But there's really not a problem with this, with having a supervisor with no children. So let's see. Let's do children equals, and let's do application get env, right? And our application is Hardhat. Now, what am I doing here? Just to explain, I'm going to make start client false. So it's going to have a default of false. So if it's true, what we will do is we will return a list that contains Hardhat. So that is our client that we generate. And we'll look here. So this module has a supervisor. Remember, we defined a child spec over here in builder. So when we get note, it says supervisor child spec, and it says module.soup. You pass it the options. So we are passing nothing for the options, but this is a valid child spec. Now it's complaining that this is not used, but what we'll do here is say we'll pass children. So maybe I need to, let's call this start default client. And that's probably good enough. What we will probably also want to do is define this in our default env, so that when it generates the .app file, the default is false. Having this this fallback value, if this key is not defined in the startup, then that's just a way to make sure that we're not getting some garbage value here that comes out as truthy. So let's or could return nil as default. I suppose that's fine. I just like being explicit, saying this is true or false. So over here, let's do what it suggests here. Run mix help compile.app. This is where we're going to define both what that key is, what the default value for that key is, as well as how to start up the application. So let's real quick look at mix help compile.app. Okay, so it spits out a lot of stuff. So this is about generating an app file. And if you have not built, or if you've just not dug into how it's built before for Elixir, what happens is when you generate a release, it creates a list of all the applications that you need, as well as it does a topological sort on the dependencies so it can know which ones need to start before which other ones. And that just makes sure that you don't start something that is expecting some other process to exist before it and then you get into weird errors where it's like trying to call this process or send this process messages and nothing happens. So the Erlang release process makes sure that you get the correct order of startup based on the dependencies. So if you have some other thing there where you depend on something, for example, if it's in the standard library, it's not listed in your dependencies because it's part of OTP. You can list it here in extra applications, and then you don't have to list the registered processes. It's just sort of a useful thing. And here's this bit. So the default values for the application environment. Let me flip back real quick to what we did here in application. So when we say application get env, that is saying get this key out of the application controller, which is just a table, like it's a process that owns an ets table, where the key is Hardhat start default client. And so first thing we want to do here is let's define an env key. And let's look at what it talks about there. The default values. So the application environment is one of the common ways to configure applications. And again, the application modules for reading and writing those. So here they say, well, key is value. Extra applications requires logger, crypto, xunit, optional, etc. And then it has some registered process names. Okay. So let's say start default client. And we do not want to start it by default. So we are going to set that to false. And then we'll write some documentation later about how to start it up. And the other thing we need to do is there are other options here. So this is the one we want. Mod. It specifies a module to invoke when the application is started. Must be the format of mod args, where args is often an empty list. The module specified must implement the callbacks defined by the application module. This is what we just built a few minutes ago. So let's go into Okay, and we don't need to supply applications or extra applications or any of these other things. Start phases is really complicated. Don't bother with it unless you absolutely need to have some kind of intermediate mode. Okay, so I'm gonna put it up here at the top. So mod is going to be hardhat.application and no arguments. So this term right here, this is what gets passed to this argument. So if we wanted to, I don't know, set something here, I don't know the exact use case. Maybe we're generating different releases and we need to pass some arguments that that give different values based on which release we generated. Honestly, most of the time I'd probably use getEnv for that, but you know, you can pass things there. So so empty list, and then that should be enough to start up the default client here. Okay. All right, and maybe let's put the registered, and this will be hardhat.supervisor, hardhat.soup, and we don't need to say any more than that. Note that this is the supervisor for the client, which, remember, what we did here was we generate this module and then potentially install the regulator if we were using regulator rather than fuse. And also it starts the Finch connection pool, and it uses the name of the client for that connection pool. Excuse me, goodness. Okay. And then, so that's hardhat soup and hardhat, and remember, this is a little bit confusing. Maybe we can go in and we can rename this module so it's like client soup or client supervisor. That might be okay. And this one is the top level supervisor for the application. Okay, so let's make sure this all compiles still. Now, what we can do too, which is interesting, notice it said generated hardhat app. That's the output of mixcompile.app. So if we look in build, dev, lib. Okay, so there's our hardhat. And it consolidated protocols. You don't need to worry about that, but let's look at what's in the ebin. Notice it generated hardhat.app. So let's look at I'm going to say language Erlang so it pretty prints it correctly. Hardhat.app. Okay, so you'll see it generates this Erlang tuple, application hardhat. And this is actually a record defined in Erlang. And you'll see there's no optional applications. The applications it requires are kernel, standard lib, Elixir, Tesla. See, and here starts our dependencies: Tesla, Finch, telemetry, OpenTelemetry, Tesla, process propagator, fuse, regulator, deadline, Elixir. Okay. And these are the modules that it generate that are contained in the application. So all the modules we've defined, the version number, and here's where we put that mod. So this is how it starts up the application. And then here's the env we defined, and here are the registered processes we defined. So just to show, this is just to show like what happens when you set those things in MixEXS here in application. Okay. And I'm going to remove that comment. and remove this one. They're helpful on your first generation, but they're not useful anymore because we know what's going on there. Okay. Now, what we could potentially do, I would really love to write a test for that, but it's going to be a bit hard because of the way XUnit starts those things up. So maybe what we should do is test it on the console here. IXS mix. And I think, let's see, mix help. Right, IEX help. Okay. I think, yeah, Elixir help is what we want, because what I want to do is pass it some configuration for Hardhat for the startup. Release options, that's not in the release. We don't need a named. The Erlang command line has a thing where you can go, you can pass the dash and then the application name and then a key and then a value, and it will set that. We could do eval, I suppose. We could do URL switches. Maybe what we'll do there is that. So IEX. All right. IXS mix. And then we're going to say, what is it? URL? Yeah. Hardhat start default client. Oops. True. Let's see if that works. Let's put it before S. Probably. Okay. So we can see it actually tried to start our application, failed to start child hardhat.soup. And it says it was already started. Okay. It also has a warning there about runtime. We want runtime false here. Okay. Yeah, it's still not starting. All right, application hardhat exited. Return an error. Shutdown. Failed to start child hardhat.soup. Already started. All right. Let's do mix no start. What is the option? Mix load paths. That's what we want. Okay. We're going to have to, first I'm going to do observer start. Oh, no driver. I don't have WX widgets installed. Okay, never mind. We're not using observer. Dang. Okay. We're going to do application ensure all started. Actually, we'll just go ahead and start that. So it actually started this time, but if we do, let's see, application dot let's just do process where is. Okay, and we can say supervisor which children of that, and it should have no children, right? So let's stop it. Stop that application. Okay. And then we're going to do, let's see what's in Hardhat. You can see start default client is false there. Okay, so let's do, I think it's put env. Yeah. Start default client true. Okay, and then let's do application start Hardhat, and we should get the same error we got before, right? Okay. So that could not start hardhat.soup. So there's a question in here in my mind about what we're generating here. And why this name is already taken. So let's go ahead in our application do output_s, because this is the thing that's conflicting. And process where is hardhat.soup. Just in case this is started up for some odd reason. And yep, then let's recompile. Okay, it was not registered. So there's a question about what, so this file just calls builder, right? So pass any options in there. All right, let's make a new tab here real quick. Let's do decompile to expanded Hardhat, just to make sure that's fresh, because what I want to see is let's jump down to child spec. Right, that's completely what I would expect. Let's run that at the command line and see what it generates. Yep. This is one of the great things about having a REPL for okay, so that just calls start link, right? This is a great thing about having a REPL. We can see what's going on there. So let's do, and so that returns the same thing. That's fine. Okay, so let's go in the application here. so these are the child specs we want to start. Inspect children. Recompile. Okay, so it just says Hardhat. I wonder if we remove the name here. The other question is, well, I guess we need the strategy. Let's look at, because there's probably something wrong with what I'm doing with supervisor start link. So let's look at that. So this takes, okay, required to provide the strategy option. Okay. Right. Okay. I don't think that there's anything wrong with our child specs there based on this. The other thing that might be going on is that somehow we're trying to start that process twice. Doesn't make sense to me, but we can look into it. All right. Trying to be cognizant of time too. I do want to get to Rust today. So we're getting a thing here where it's trying to start a process and that is not started yet. Like this process does not exist, and yet in the middle of our startup, oops, lost my editor there. Okay, in the middle of our startup, we're telling it to start that process, right? The reason why I'm actually really concerned about this is that it is that we if we can't start this as part of our own application, then there's going to be a problem if you try to start this supervised. Now, what's weird to me is that it didn't happen in our tests. So, like, maybe run the test suite again and see what happens. Yeah, there's no problems when we start it individually in each test with the, because in our tests we're using start supervised, right? Um, yeah, there's nothing going on there. Okay. One thing I'm concerned about is let's run mix decompile again. Let's see what hardhat.soup looks like. I don't think it's anything surprising. Right, so its child spec is generated by um, use supervisor. It's interesting it doesn't generate behavior supervisor in here, but whatever. Um, so so that's what should be started. And that's what we were getting when we did. So if we do Hardhat child spec, we get that. If we do hardhat.soup.childspec, we get back the same thing. So it should only be, and that's what we did. I wonder if we should generate in the builder, instead of this, we should do this. I don't think it's going to make a difference. But let's try it. Okay, that's the same, right? That's the same. Hard hat. I don't know if that works. No, it doesn't. It's 2. Right? Okay, so should be nothing surprising there. Let's run the tests again, just to be sure I didn't break anything. No? Okay. This is interesting. If you've dealt with this before, let me know. I'm kind of struggling with the lack of visibility into the application startup. So what I might do we can pull in recon again. Remember previously we had recon in here for tracing, because I think that that's probably going to show us what we need to know. Recon hex, fine, recon. Yep. 254. Okay. Helps if I type compile, but it compiled anyway. Okay, X mix load paths. Okay. We're gonna make sure that we can start up without the default client being started. Okay, we're doing fine. And then we're going to stop it. And then we're going to set start default client true, right? Okay. And now, before we try to start this, let's recon trace. And I think what we want to do is let's trace hardhat.soup anything, right? And it's a good thing I pulled up the docs, because I need to recall it's recon trace calls. Recon trace calls, and then we want basically any function, and that limit is 1. I think we probably want to say, I don't know, something like 100. Just to make sure that we're not yeah, and that has to be an atom. Let's trace 100. So it's not going to call it that many times, but let's application that. Okay, we didn't get anything printed on interesting. Application failed to start. Hardhat already started. Do we have some kind of circular thing here going on? We might. Okay. So all right. We're going to make some changes on naming just to clarify some things. Let's call it pool. Let's call it connection pool. And then that way we know that this is starting up with a different name than something else. And that we can disambiguate this a little bit. Right, okay. And that's fine. Okay, so just to clarify again, what I said was the name of the Finch connection pool is going to be our module.connectionPool. And then we're setting it here. So, because what it looked like to me was, because we named it just the name of the module, which was fine when we didn't have an intermediate supervisor. But in this case, we have an intermediate supervisor. That's hardhat.soup, right? And so I want to make sure that this is a problem that is not happening because we named some things the same thing, if that makes sense. Okay, so let's recompile. Make sure there's no hardhat. There's no hardhat.soup. And hardhat as supervisor. And I think we need to rename. We need to rename this. Maybe we'll call it client supervisor. All right, and let's do that. It started. Aha. Okay. So probably what was happening was, when we say, okay, hardhat, the supervisor here takes this as, well, I'm going to try to register this name hardhat. And that registered name, so actually we can see here. So process, where is hardhat? That's nil. Hardhat.soup is there. Connection pool. I really wish we had observer, but I don't have it set up correctly on my install. Okay, so we disambiguated some things. But let's do supervisor which children on hardhat.supervisor. Okay, so it has that, and let's look at that. What children that has the connection pool as worker Finch. Okay, so just for clarity's sake, and I think a little bit of sanity, I'm going to close that. I'm going to change the name of this. So let's see if we can rename symbol. No. Okay, we're going to call this client supervisor. And then let's change it here too. That's the only other place, I think. Okay. Application stop. Hardhat. Okay, recompile. Okay, and then let's do, right, okay, so now it says client supervisor. I think that's a little bit clearer. Yep, and then let's look at the children of that. And we got connection pool. Okay, that's a little bit clearer. And we won't run into that problem. It's not clear to me why that happened. My guess is it's a conflict between the name of a child and a supervisor and a registered name. But at the very least, we are not going to run into that problem again. Okay, so let's make a commit here. We can quit. We don't need that anymore. And I need to revert the recon. And honestly, I'll just leave it commented out because I may want to add it again later if we're doing any more debugging. Okay, so mixed steps.get. I think we can probably just check out mix.lock. Let's reset that. Okay, so we renamed that to connection pool. We renamed that to client supervisor just to be a bit more clear. I don't know that this change is strictly necessary. Let's go look at that one more time. I mean, it is necessary for the naming, but maybe we do... like that. That's more like what it was before. And just for sanity's sake, let's... I think it's ensure loaded. Let's look. Ensure loaded. Right. Let's just make sure that the defaults for that app are loaded into the environment so we can see that it's got that. So let's set that again. And that needs to be an atom. Okay, and we're fine. Yep. Okay. We're good. And I don't think that that didn't have any material change, but it's at least a little bit more consistent with what we had before. Okay. So looking at the diff, we changed the name of that process to connection pool. And then we're starting Finch with that name rather than the name we had before. We renamed the supervisor to client supervisor. We set up the application. We set Elixir as runtime false. We should run mix dialyzer real quick just to make sure that that still will run in in CI that we didn't break anything by saying that's runtime false. I think that's the appropriate thing to do. Yeah, it's fine. Okay. One more time. And then we add the application behavior. So lib. So we have the application. Okay, add, let's just use the editor for that. Add application behavior that allows the default client to start up at boot. Okay. In config. Okay. That's good. Let's push that. All right. And let's look at our to-do list. So that's pretty good. As always, if you have questions, you're wondering what I'm doing, you're like, Sean, this is crazy. Why would I ever do that? Please drop them in the chat. I'm happy to answer at any time. And real quick, I'm going to get over here and turn on the fan. It's a little warm up here today. And yes, I am wearing a U.S. Women's National Team jersey. They are playing right now, or they're about to start in just a minute or two. And I'm repping Rose Lavelle, number 16. Okay, so, I took about it. I said I'd try to divide this about in half. I would like to take a little bit longer and write some README examples. I don't think we're going to get to release actions today. Unless we just keep going with Elixir. If y'all want to do that, that's fine with me. And we can get to Rust some other time, although that's another broken promise. How about let's at least outline what the examples should be, what we should talk about in the README, and cover some of these things that we are doing automatically that can't really be determined by module documentation. So yeah, let's go to the README and get started. Okay. So most READMEs have something about installation. So we'll say add Hardhat to the dependencies in your mix.exs, and we'll say this is Elixir. And it's probably 2 deps. Love that embedded highlighting. And we'll say Hardhat 1.0.0. And I'm just saying that because we'll eventually have a 1.0 release. And I'm not about to generate that from whatever the version is in the mix.exs. We will have a 1.0 as the first release. I know that's not typical, but I'm confident enough with this code that we've written, as well as the pattern, that we can go ahead and say it's 1.0 in this. Okay. So we'll say Hardhat. Come on, John. Hardhat requires that you create a connection pool. What do we want? We want to say, okay, so that's installation. Fine. So we'll have a getting started section. And what I want to do in here is I'll just write to-dos and then we can go back, because I'm sort of a top-down thinker. If we were doing this in Emacs, I'd be writing org mode. And then we would have like an outline, and I would just fill in the sections there. Okay, so So what we're going to do, define a module, supervise that module, make calls. Okay. And then what we should talk about is we should talk about connection pool. And then something about like sizing the pool, Finch options, etc. Okay. We should talk about telemetry and tracing. So here we're going to talk about the telemetry events. Telemetry events, open telemetry spans and events. Propagation is something we want to talk about there. Okay. And we're going to call this section failure detection. In here we're going to talk about fuse, mode, and configuration, as well as regulator. We'll use caps on that. Mode and configuration. Okay. Time. So let's see. I want to move this up because that's included in the default stack. So, and actually, before we talk about connection pools, let's let's have a general behavior section, which is going to talk about the contents of the default middleware, and we'll link to other sections. Okay. Right. Okay, so circuit breaking, let's talk about retries to do, and this is really just default options and so forth. And maybe we'll have a note about interactions with failure detection. Right? Okay, and then timeouts and deadlines. And then we'll talk about the custom timeout middleware, which it will include a reference to the OpenTelemetry. Let's put backticks on that so it gets linked to. Custom timeout middleware, deadline, support, etc. And then we'll have to talk about some other bits, probably. Maybe we should talk about testing. Stuff about like overriding the adapter to use a mock or bypass. Maybe section would be like suggestion would not be normative section. I don't really think that we should really tell people how they should test, but maybe more like how can you tweak it so that you're not actually calling the real thing. For example, you should not be calling the Stripe API in your tests if you're writing a Stripe API wrapper. So this should have some examples in it. All right, so let's maybe write this example first. what's a good API that we might want to talk to? I mentioned Stripe just now, but um, maybe you want to talk to the GitHub API, or maybe we want to talk to maybe the Twitch API. I don't really have any documentation on the Twitch API, but we could potentially do that. So let's say def module. Um, I know. Let's make a Mastodon API. Okay, and we'll say use Hardhat. There's really not that much there. This is kind of the default thing that we want to show people. Um, and then okay, so let's put some comments here. Define a client module. In your supervisor, we're going to say, well, what do we say instead of add it to your supervisor? So we'll say def module my app.soup use supervisor. Does that inject the start link? I don't recall. Yeah, this is all from about calling it from the outside. No, we need to do that. Okay, so let's just copy that. Okay. Oops. This is one thing that always bugs me about Dash is it doesn't show up in the command tab menu. Okay, so it's basically like this. And I think I selected the whole thing. Yep. Okay. And we're not going to do counter. We're going to say Mastodon. Excuse me. Okay. Let's rename this to Social Media API. How's that? Then we're not being we're not being partisan, since the whole thing is fracturing nowadays. Okay, so this would be the client for our social media API. And I'm going to say this is required. And then we'll say use your client to make requests. So this is the basic getting started. Social media API dot get HTTP social media API dot social. We're making this up as we go. And posts and so forth. Okay, so that's a basic example. I think that's pretty good. So I want to say here, I'll leave that to do for now. I'm going to say Hardhat is designed to be easy for creating quick wrappers around HTTP APIs, but includes many options for customization. To define a simple client, do something like the following. Okay, so I think that's probably good enough. Let's remove. Oh, we can put backticks in that. And one thing I want to do here, as mentioned in the example above, it is imperative for you to supervise the client defined by the use Hardhat. I want to say, like, define the client module, supervise the client module that includes the use Hardhat macro. See connection pools. I think it's going to be like this. I don't actually remember below for more information. Not supervision, you will, without starting the client under supervision, you will not be able to make requests. Okay. All right, so then we can talk about that more in the connection pool section. So general behavior, I want to cover like all these bullets that we talked about above. We'll talk about what the default middleware is, as well as the fact that you can use Tesla, macros and middleware freely in your own client. Okay, so let's say Hardhat is built. Keep my to-do comments at the top so I can delete them more easily later. Built on top of Tesla and uses Finch as the adapter. Because Tesla is the foundation, you are welcome to utilize publicly available middleware in your client, in your Hardhat based client. And I'm gonna Tesla.middleware because most everything is like that. Modules. Let's make another example. Okay, some JSON API. And then what I'm going to do here is I'm going to say use Hardhat. And we'll say plug Tesla dot middleware dot base URL, and we'll say HBS my JSON dot API. This is just examples, so we don't actually have to care about them being accurate. Tesla dot middleware dot JSON, and so forth. And there's let's see, Tesla middleware. Yeah, I think there's other stuff in there. In addition to the adapter selection and default Tesla behavior, use Hardhat will inject will inject the common functionality listed above. I know this is not the most riveting stream content, but we'll wrap up by the top of the hour, and then we'll do some rest. And I may even finish this on my own time. I don't think this makes great for good learning, but just to say, if you are building an open source library in Elixir, I think that the community standards are really high for good documentation. So it's worth spending your time writing this. I did something similar. This is pretty good, but when I wrote this library the first time at a previous job, I basically wrote the README first. Before I wrote any code, I was like, here's what I want it to include. Here's what I want the API to look like, and I use that as a guide for implementing the features that we've done here on the stream. Now I kind of reversed that process, mostly because I didn't want this to be boring. I wanted it to be mostly focused on code, but these are the sorts of things you have to polish when you publish. So what we'll do in the next 12 minutes is we'll finish writing this. We'll maybe write one more section, and we will bump the release candidate version and push it to hex, and generate the docs and so forth, and make sure that we are we're getting the right stuff. Okay, I'm gonna break lines there. I don't know how it's going to generate. Let's look at let's maybe find it in Xdoc. Okay. Yeah, that's not here. Xdoc. Xdoc. Does this have guides? Yes, it does. Cheat sheet user guide. No, that's for creating a cheat MD. Okay. The mixed docs. Okay. We don't need to source URL pattern. All right, we'll want to make sure we set that correctly in a little bit, but helpful. All right, let's see the main page. This is probably going to tell us something. uh, auto linking. Okay. For duo module function. Okay. Elixir. Okay. OTP. Right. Depths. Linking in modules. Okay. That's fine. We've already used that, I think. Like to extra pages. Ammunition blocks. We may want to make use of that. We'll see. Tab sets. We won't need that. Extensions. We don't need to render math. We don't need to render Vega Light, although that's cool that you can do that. Mermaid graphs. I really just wanted to find out, like, what is... Okay, so it looks lowercase. Contributing. Right? Like, this is... Okay, lowercase was... Yeah, lower stabby case. Okay, so we could do... It's probably going to be like this. And I need to fix this, so that's connection pools, right? Hopefully it doesn't try to double fix that for me. Okay. Those are... so, in addition to the aperture selection and default Tesla behavior, use Hardhat will inject the common functionality listed above. That functionality... okay, so I'm going to put after any middleware that you supply via plug. And we're going to link that tesla.builder.plug. Okay. Plug 2, because it's a macro. Okay. The current list is as follows. And let's just, let's list what the builder has. And I close that out so we can get a little bit more space here. Split left. And what does the builder inject? Okay. Hardhat.middleware .deadline propagation. Tesla middleware retry. Either Tesla middleware fuse or Hardhat regulator. Let's make a link for that. And that's going to be failure detection, right? And we'll do Tesla middleware.telemetry. Tesla middleware open telemetry. Hardhat middleware path params. I'm going to write a caveat here. Okay, so I think we can remove that split now. I'm going to write a caveat here about timeouts. With the exception that we recommend you use Hardhat middleware timeout. Tesla middleware timeout. And then I'm going to make another link here. So the main thing is just like providing enough context so that, you know, it's kind of a getting started guide. But we're making sure that the person who's coming to this for the first time is able to jump and find the information that they need. So like this is going to be a long document. I don't want people to feel forced to like scroll all the way to the end to find what they want. If I've got an opportunity higher up in the document to point to something that they might be interested in, I'm going to do it. And some of this is just that it's hard to represent something that's kind of like a mesh of ideas in linear prose. So I'm trying to use as much as possible what the like the different sections of this document. Okay, we need to wrap up. I didn't get to do everything I wanted to here, but this is also a good place to stop, and we'll flip over and do some Rust, which I'm sure you all have been waiting for. I like writing Rust. It's fun. So maybe for next time, or if I'm feeling up to it on my own time, not on stream, we'll fill out the rest of this document. It's going to be a lot. And you know, we're going to have to make sure that this is really, really well documented before we push out 1.0. So I'm going to jump in here. Let's really quickly, let's bump this to 3. And let's make sure that we can generate the docs still and that they look okay. And just for sanity's sake, I'm going to remove the docs directory. Mix docs. Okay, and let's doc index.html. Thanks for coming. So like the stream first time here, would love to pick it from session 1. And unfortunately, session 1 was lost because I was a doofus and didn't record it correctly. And yeah, but thank you again for coming. And I really love that that you showed up. Okay, so something's not right there. Did I save this? README MD is saved. Okay, so I know what the problem is. I need to recompile because that is a thing that we're gonna do real quick, because I think that, okay, I'm getting lost here in my windows. Where did, it's because it popped up a little arc. Okay, we need to, in here, we need to say external resource, readme.md, and then it'll regenerate this module whenever we change that file. At least it should. Okay, run mix docs again, and open doc index. text.html. And let's go ahead and put it in there. Okay, so now we have this. Let's see, is that module what's included? So I'm guessing that this link down here that I made, that's not going to jump to anything, right? And that's not going to jump to anything. So we need to fix those real quick, and then we will move on. So this is going to be module connection pools, because this is module level documentation, right? And part of this is that we are not putting this in directly in the module. We're putting this in the README. So one caveat of that is that it's not going to work on the GitHub README, but it will in the hex docs. And I think I'm okay with that trade-off. We might revisit it at some other point. Module. And that's all the links we have. So, yep. And notice it recompiled our module there because we changed the docs. So let's go back over here and refresh. And now we're jumping down to timeouts and deadlines. So we connection pools, it jumps to connection pools. Here we can jump to the listed above, it says what's included. Okay, so I think that's a pretty good place to stop. README lib mix. Let's see what's in the diff, right? We added all that stuff. Okay. So update README and bump to RC.3. We're going to tag 1.0.0 RC.3, and then we're going to push with tags. Okay, and then we're going to mix hex.publish. Yes. Okay. So that's all we're going to do for Elixir. So I'm going to take a quick transition and then we'll start on some Rust.